large number of templates have been made by photographic methods for use in the manufacture of the free flight and wind tunnel models. Many wind tunnel models are being produced, and constant liaison has been maintained between design, photography, and experimental manufacturing, where some models are being built, and Cornell Aeronautical Labs in Buffalo, who manufacture and test. Dimensional accuracy on the templates has been held to plus or minus 1 thou in order to meet the rigid requirements in manufacturing and testing. After preliminary cutting, the templates are filed in an optical filing machine with which the 1 thou wide line can actually be split. This kind of accuracy has been held on both templates and models which have been made at Avro and Cornell. In many cases, dial gauge indicators have been used along with the templates to achieve the required accuracy in the finished components or completed models. The manufacture of the templates and the models is a demanding operation, and the accuracy of the data received from the wind tunnel tests depends entirely on the faithfulness of reproduction of the model from the design. While a great deal of wind tunnel work will be done by NRC in Ottawa, most of the preliminary work has been done at the Cornell Lab in Buffalo. Their supersonic tunnel has provided much data which has proven existing design or shown the need for design changes. Disassembled models were first shipped to Buffalo in June 1954. After unpacking and checking of all components and detail parts, the model is assembled on a sting. This serves as a support for the model and as a pipeline through which passes the umbilical cord used to transmit the information which must be relayed from the model to the control room. One prime example of the value of the wind tunnel has been a design change made in the top lines of the canopy to cure a turbulent condition at the tail, which was indicated in the tunnel tests. When the turbulence was found to exist, tests were carried out in the NRC water tank at Ottawa using a scale model wooden canopy. Progressive changes were made in the shape of the canopy and the turbulence largely cured. To meet the requirements of the tests, control surfaces at a variety of angles have been manufactured and may be installed on the model to determine the varying effects under changed conditions or attitudes. At this point, the sting with the model fully assembled on it is carried into the tunnel for erection in the test area. When the assembly is fully installed in position and all electrical connections are completed, the tunnel entrance is completely closed and all operations carried on from the control center. In every phase of development, the test program has been particularly vigorous so that when we eventually do get to the production stage, most of the design problems will have been sorted out without having to resort to an excessively long test and modification program on the prototypes. Complete control of all conditions is achieved, and the recording of all results is made in the control room. The control room engineers may change the conditions affecting the model at any time. They can, by means of television, observe the model undergoing testing, and they can directly see the result of the tests on various gauges and meters. The interpretation of the figures is done by the aerodynamics people, and the information is passed to the design and stress offices. They incorporate the required set of conditions or changes into the design and stress specifications. So far, 5 wind tunnel programs have been conducted at Cornell. Many more will be required. Most of the aerodynamics tests are carried out in a Canadian government wind tunnel at Ottawa. Flutter analysis of the Avro presented several problems that could only be adequately solved by the building and testing of a scale stiffness model to afford a practical check against theoretical calculations. Air is forced into the tunnel and the control stick is pulled back to effect a takeoff. Action of the control stick moves small auxiliary flaps which trim the model during flight. The model tilts up, obtains lift, and flies off its bottom support into the center of the tunnel. Avro commenced a spinning test program in January 1957. These tests discover what conditions will cause the aircraft to go into a spin, and what control actions must be made by the pilot to recover normal flight. The dynamic scale model is launched with an initial rotation into the vertical airstream. Scaled to 1/24th size, the model contains a magnetically operated remote control mechanism for movement of the rudder and ailerons, pilot orientation and design information for an anti-spin parachute are other questions to be answered in further spinning tests. Scale models of the Sparrow 2 missile were made to investigate the proposed jettison procedure of the aircraft armament. The tests examined interference behavior of the missiles while being jettisoned under various level flight conditions. The dynamic models were released from their mountings below a scaled aircraft in the wind tunnel. Aerodynamic and jettison characteristics of the externally mounted long-range fuel tank were also determined in the wind tunnel. Models of the drop tank installation have been prepared in different weights to meet the various requirements for wind tunnel testing of these characteristics at different altitudes. The drop tank's airflow behavior is learned from study of filmed records. The free flight model program consists of building a series of 1/8 scale models designed to be released from a ground launching platform with the aid of a rocket booster. The models are made of magnesium, and most of the major parts are castings. Wooden patterns were made in the experimental manufacturing shops with the aid of photo templates to achieve the desired lines. A long, careful process is necessary to keep the tolerance within 5 thou. This accuracy has been maintained throughout the free flight model building program, which carried on through the summer and fall of 1954. It was originally intended that light alloy castings be used for the wing, and a number of attempts were made in this direction. It was found, however, that the resulting castings were badly sprung out of shape, and time would not permit a solution to be found to this difficulty. For that reason, it has been necessary to resort to a completely fabricated job made in many parts and assembled to form the required delta-shaped wing. We have seen how the original design philosophy has been interpreted into wind tunnel models, which in turn have dictated change requirements in subsequent versions. These changes, as they are recognized, are incorporated also in the free flight models. We have seen, too, how the accuracy of the data from wind tunnel testing depends on the skill with which the models are manufactured. So, too, does the data we hope to get from the free flight of these 1/8 scale models depend on the men who make the patterns and the castings and those who do the finishing and assembling. When the free flight models are flown, they will be boosted away from the launching platform by a Nike rocket, which will accelerate the combination to a speed of Mach 1.9. At this point, the booster will fall free and the model will coast. An extensive array of electronic gear installed in the model will record and transmit the necessary information to the telemetry installation on the ground. Prior to the flight of the actual models, a series of crude models are being launched. These are also 1/8 scale, but they are relatively rough and inexpensive. They have laminated wings of wood and steel with a steel fuselage containing ballast in the nose. They contain electronics similar to that in the final models, and their flight will provide much of the background information which will be required in order to conduct an efficient program of launchings. With the crude models, we will gather much valuable information regarding launching technique, and separation of the booster model assembly from the launcher. The Avro launching platform itself and the separation of the booster from the model will be proven. The performance of the telemetry setup will be indicated, and the electronic installation in the model will be proven satisfactory or otherwise. The checking out of the transmitter is completed in the experimental hangar to ensure that any effect on the model will be accurately transmitted so that a record may be made. This transmitted record will be the only one available since the model cannot be recovered after flight. The launching program got underway at Point Peter Range near Picton in December 1954. At that time, 2 of the crude models were released. The model and its booster rocket were first assembled and installed on the ramp of the launching platform. This was completed in the assembly shed, and the unit then moved to the launching site. Complete instrumentation was done to ensure that each unknown could be recorded in some way as the model flew at tremendous speed through space. Special cameras were set up at many vantage points to provide a visual record of the flight and to assist in plotting acceleration, speed, and direction. A radar tracking system was set up as an additional means of recording the flight performance. High-speed cameras were set up to record the action taking place at the moment the model and booster would leave the platform. If anything was going to go wrong at this stage, we would want an accurate picture which would help to tell us why. The ramp of the platform was elevated to an angle of 47 degrees for takeoff, and the whole platform leveled at the launching site in the final stages of make-ready for the first launching of a crewed free-flight model of the CF-105. Kinetheodolite cameras were installed in 5 locations to track the models and provide results which, with triangulation, show the velocity and acceleration. This information, along with the telemetry figures, gives us an accurate picture of the behavior of the model. The model and booster assembly, installed on the launching platform ramp, are completely checked out at the launching site and all final preparations completed just prior to the launching of each model. The model-booster combination leaves the zero-length launching platform and accelerates to Mach 1.9, at which time separation takes place and the model continues to coast. The accuracy of the design data and the calculations relative to this phase of the design program were proven to be quite good with the first 2 launchings. In the summer of 1955, final preparations were completed prior to shipping the first drag model to the Point Peter Range. It was swung in this way to provide weight and balance figures which would be related to the records we would obtain in order to show drag and other flight characteristics. Investigations had been conducted with the use of area rule to determine the drag of the aircraft, and we found with the flight of these models that our experimental results were in close agreement with theoretical calculations. Throughout the program, the free-flight models have been changed as necessary to incorporate the changes in the original design which have been dictated by the results of wind tunnel tests of the scale models. The progress in the design as a result of information so gained is exemplified by these views of free-flight models prepared before and after design changes incorporated as a result of investigation of the effects of area rule. All flights of the models are recorded in minute detail by a telemetry unit in order that a maximum amount of information may be obtained from each launching. Of the 4 models seen here, 2 are models for measuring drag and 2 are used for checking directional stability. The latest available resources of many sciences are represented in the extensive and intricate recording and computing apparatus employed to note and to evaluate the information transmitted from the free flight models. Here, the instruments used for transmitting information from the models are being calibrated on a centrifuge under high acceleration conditions. In addition to the firings which have been carried out at the Cardi Range at Point Peter, 2 firings have been carried out at Langley Field, Virginia, the facility of the National Advisory Committee for Aeronautics. The evaluation of drag in free flight models requires a very extensive instrumentation of the range, which was not available at Point Peter at that time. The Virginia facility was also equipped with Doppler radar installations which are capable of high precision tracking of models in flight. The model and booster assembly installed on the launching platform ramp are completely checked out at the launching site, final preparations being completed immediately prior to the launching. After the model and booster assembly is mounted on the launching platform, the ramp is then raised to the launching position, an angle of 45 degrees. The model booster combination leaves the zero-length launching platform and accelerates to Mach 1.8 approximately, at which speed separation of the model and booster takes place. The model then continues in free flight. Concluding the program, model number 11 was fired on January 10th, 1957. The free flight model program proved to be a successful and relatively inexpensive method of obtaining the required drag and lateral and longitudinal stability data. Analysis of this data verified original prediction and helped to ensure the success of the Avro CF-105.